Alright, hello everybody. So today we're going to discuss the property of equality solving tools. Now, these tools are essential when solving equations. Now, there are 7 laws that we can apply. We can either add both sides, subtract both sides, multiply both sides, divide both sides, switch right to left, so interchange the sides, combine like terms, and apply the distributive law. So briefly, I'm going to go over each law and highlighting what we're able to do, and then perhaps giving an example of how to utilize this law. But before we begin, let's just briefly discuss an equation. Now, an equation, just to think of one, can be something of the form like 2 plus 9 is equal to, let's see, 13 minus 2. Now, for an equation to hold, the right-hand side has to be equivalent to the left-hand side. So that means that even though they may be represented in a different form, they must be equal at the very end. Once we manipulate the problem, we should have the result of the left-hand side should be equivalent to the result of the right-hand side. So let's see if this is true for just this example. If I were to add 2 plus 9, I get 11. And then 13 minus 2 is 11. So we see that this equality is held in this problem. So now, the problems that we're going to be solving aren't as simple as this, and it's not just to state that the equation, both sides of the equation are equivalent. The idea is that now we're going to be given variables. Now, variables are usually represented as letters like x, y, z, and even ABC, any value like that. This could be a variable. Now, variable is a value that replaces and can represent any number any number. So it's basically like an unknown. And when we're given an equation, we are asked to solve for this unknown, where we apply these 7 property of equality solving tools in order to solve for the variable. And as a result, we will then figure out what value the equation will suffice and hold the equality for. So yet again, the left-hand side will equal to the right-hand side. All right. So we'll begin by just discussing some of these properties. So let's erase this first. So our first property is we can add both sides and then subtract both sides. So I'm going to do these two together. Now, before I begin, the way that I picture an equality is as a balance or as a scale, right? So imagine we have these two scales. The idea is that we want this to always be balanced, no matter what. So imagine that we have a quantity on the right hand side with some sort of weight, and these different circles and squares represent a varying weight, and somehow we can have some different masses, different weights, and we want to be able to so that both of them are equal. Now, the idea when we add both sides and subtract both sides is that what we can do is we can add something to both sides the same amount. So say I add something that has like weight star or something. I would have to add it to both sides, and if these were if this scale was balanced to begin with, then by simply adding this star, whatever it may be, whatever weight, the scale will remain balanced. Alright, so that's the idea behind adding something to both sides. Remember, we want to keep, since it's an equality, since in the equation the equality must hold, so the left hand side must equal to the right hand side, and if we add something to both sides, the equality should still suffice. Alright, now to go back to subtracting both sides, imagine I were supposed to just take out these stars that I just added. We'd be back with the beginning, so then that means that before we even added these stars, the scale that we just drew was already balanced. So that's the same idea with just subtracting something from both sides. If we take the same amount from each side, and if the scale was already balanced, then doing so will not change the equilibrium of the scale. So the scale will remain balanced. So now these ideas can be extended to both multiplying and dividing both sides. Alright, so now, see, I'll try to illustrate this in another picture of how multiplication is the same thing under this equality tool, as well as division. Okay, so let's go back to this scale. Now, I have this scale. It has a certain amount of objects inside. Now I use some circles and some rectangles and some triangles. Each one represents a different mass. But the idea of like multiplying both sides is that we would add a grouping of some object to both sides. So for example, I can add a grouping of 2 pairs of circles, which I'll indicate like that. And then if I added that to both sides, if the scale was balanced to begin with, doing this application will not change the balance of the scale. This scale will remain balanced. So the idea is that when we multiply something to an equation, it must be applied to both sides to preserve this balance or this equality. Now the same thing applies with division, where if I wanted to take a grouping out, we would have to take the same amount of on both sides, the same amount of grouping. So imagine I already added those 2 pairs of circles that have some sort of mass, and they held the balance of the scale. Now through division, it's the exact opposite, where instead of adding a pairs of grouping, some grouping of an object, we will begin to take away groupings of objects. So through division, I would just end up taking away these pairs of circles, and by doing so, the scale will still be balanced, and that's essentially the idea. Now, when switching right to left, that's basically just looking at the one side and then the other side. Alright? Now, the combining like terms, that's something that we're going to see when we actually go through some examples. And the distributed law, I'll lightly touch up on that right now. So first I'll begin by erasing all this stuff. Alright, so let's begin by seeing what the equality law states. I mean the distributed law. Excuse me. The distributed law states for any number, let's say a, parentheses b plus c, this is equivalent to saying a times c plus a times b plus a times c. Alright, so you see what occurs is that this a value gets multiplied to whatever is inside this parentheses. And now let's illustrate this using an example. So say I have 2 outside and then 3 plus 1. Now, by applying the distributive law, this tells us that 2 is going to be multiplied to 3, and then 2 is going to be multiplied to 1. So it's going to be 2 times 3 plus 2 times 1. Now remember, we're saying that these two sides are equivalent, so think of the balance. So the distributive law holds as an equality, and everything should be balanced on a scale if we were to imagine it as a scale. So unraveling this right hand side, we have 2 times 3 gives us 6, 2 times 1 gives us 2, and then going further, we have 6 plus 2, which gives us 8. Now I want to work the left hand side to illustrate that this is exactly the same as what we did in the right hand side, where we will get the same result, because remember, distributive law holds equality. So we have, I'm going to leave 2, and then by order of operations, we want to work inside the parentheses. So 3 plus 1 gives us 4. Now 2 times 4 gives us 8. So you see that the distributive law holds under equality. Now combining like terms is something that we're going to have to utilize when we're solving equations. So with that, I would like to look at some examples where we're applying these two equations. Alright, and that will be looked at. So we'll look at some examples in the next video.